Hi class, the next lab, which is based on spectroscopy and chromatography, is really an instrumentation lab where you're going to learn how to acquire a gas chromatogram, where you're going to learn the principles of chromatography through TLC. So we'll cover GC, we will cover TLC, and in spectroscopy we will learn how to run an IR. And while we are not going to run NMRs, we will learn how to interpret that. So it still is going to be like a dry lab component. NMR is going to be through a dry lab component. And we will also have a mass spec, which is also a dry lab component. So overall, you're going to be doing 5 different things, and the percent points towards your grade is 5% as well. So do not miss this lab. Okay, let's see what the lab would entail. There is a video that we had developed which talks about TLC and how to run the TLC, but I'll still briefly go over the sketches and what the principles are in this video. Let's go over each of these techniques one by one. Of course, I'm going to be covering the principles and the idea behind what to expect, how to read, etc. I'll do that in class, in lecture, because that's a part of your lecture, the theoretical part as well. But I just want to cover what is expected of you on that day. Now, the specific instructions which are pertinent to the instrument, those will be given by the lab tech once we are in the lab, so that we prepare you. But still, I want to take the time to let you know what to expect. So under lab related documents, you're going to see a file that says spectroscopy, TLC, GC lab, and then there is a TLC video, and then of course this is the third resource for that. The first page of that will talk about IR. So IR, as we will learn in lecture, is a technique that enables us to distinguish between functionalities, because when you irradiate an infrared radiation, essentially you're looking at the differences in the electronic movement. And so if there is a dipole that can show differences in electronic movement in terms of the amount of energy that is being absorbed, it's reflected in the IR spectroscopy. So you would be given 4 liquid samples and 2 solid samples. And so in case of the liquid sample, all you got to do is you run it on a sodium chloride salt plate, is what it's called, salt plate. And like I said, it's made of sodium chloride. It's a special type of very pure sodium chloride. Please do not put water on that, because obviously it's going to dissolve. So when you come over there at the station, you will cleanse the salt plates. You're then going to load your sample, and the best way to go about it is basically cleanse it first with acetone. So cleanse with acetone, and the reason for that is because you don't want to trust who used that before you, so just go with as if it's dirty. After you have wiped it with Kim Wipe, so we do not use a regular paper towel, but rather Kim Wipes to remove any traces of acetone, because you do not want to obviously get acetone as a contaminant in your IR. Also, you should touch the IR plates from the edges, not from the face, because it's going to leave a smudge from your gloves or your fingers, and that's going to be recorded as a part of your sample as well. Now, after it's nice and clean, what you do is you take one of those Pasteur pipettes and you put in 1 to 2 drops of the sample of the sample. Okay. And you put the sample, you sandwich it with the other IR plate. So I'm going to just change the color. And so the sample is in between. Sample. And it's sandwiched between these two IR plates. You hold it by the edges, and you're going to load it in the IR instrument in that V type of a shape on that black window. That's the path of light, essentially. And again, the lab tech will show you exactly where that spot is. And then you give the instruction on the software. You basically hit scan, and you let it scan. And as it scans, it usually takes about 2 minutes or so. And past that, you would get your spectra. And at that point of time, you would then label it. So each of your spectra should be labeled. You label it. You print it. And in order to print, you should just right click and hit print, and that prints a good copy. If you go to file and print, it will print out like a really small copy, and that usually is of no use. So right click and print, that's what we are going to go with, and that'll be it. So really hitting the button, scan, label, print, those are the three things you have to do. Sometimes we see that our sample is too concentrated, and the reading that we get on our spectra, so let's say this is the spectra that I obtained, the reading is so much, the sample is so much that all my peaks are, kind of going through the page. In that case, we have to run it again, and we'll have to, or there will be like broadening of the peaks at the bottom. Now, as we learn, some of the peaks are supposed to be broad, but in this case, all of the peaks will be broadened. So that's the way you distinguish between a good IR and a bad IR. And if you have broadening of peaks, then we will ask you to rerun your IR and redo that particular sample. As far as the solid samples go, what you do is you don't load the sample by itself. What you do is you make a slurry of the sample in mineral oil and put a dab of that on the salt plate. You still sandwich it, but then when you run, realize since you have put this in mineral oil, which is also referred to as Nujol, you are going to see that in your IR. So right around 2900-ish or so, you're going to see a big peak that's not coming from your compound, but rather from the Nujol. And that's okay, because it's expected to do that. Now, so that's IR. As far as the GC go, let's talk about that. So in case of GC, you'll be given a three-component mixture. And so what you're going to do is you're going to essentially run that, inject that in the GC. Now, this particular one, actually, the lab tech does it for you. So you just interpret it. And actually, throughout the semester, that's what we are going to do. A GC is actually an analytical technique. It's not really spectroscopy, but rather an analytical technique that gives me information whether I'm dealing with a pure sample or whether I'm dealing with a mixture. So the number of peaks that you get at the end of the day is equivalent to the number of components that are present in the mixture. And the area under each peak is reflective of the percentage composition of the mixture. So that's what we go with. Also realize that a GC is based on the boiling points of the components. So higher is the boiling point, it will show up later in the GC, and lower the boiling point is going to show up earlier. So you're going to run a three-component mixture, and basically your task is to identify what's what. So let's say this is what you get. You have to label on your GC spectra. We also tell you the components. Please refer to the student notes for that, but figure out which peak is which, and that's the aim. You have to label the GC, and you have to take notes as the lab tech tells you, but you will need to give me information on the flow rate, the temperature of the column, and the carrier gas. Those are the three basic parameters that you have to provide some information on. As far as NMR and mass spec go, the 4 samples of mass spec, the mass spec is already loaded in that file, and so is the NMR for the 6 components. You just have to match which one is which. So like I said, you're not going to acquire anything in those particular categories. You're just going to read and interpret. So you will be turning in those sheets as is, and you will show your work on those sheets, and you will discuss that work in words in the main text of the lab. So essentially realize that you're going to be running these 5 as, one will be under the spectroscopy heading, which will entail your IR, it will cover your mass spec, and it will cover your NMR. So those 3 will be worth 3% points, and the GC and the TLC, those will be clubbed together, and they are for 2% points. And like I said, for the TLC, there is a video that you have to watch, and I'm going to, there is a handout that you have to, that gives you the entire information procedure and all of that good stuff. And I'm just going to cover like the very basic as to what's expected of you in the GC part. Oh, I'm sorry, TLC part. So let's talk about the last bit, which is TLC. TLC stands for thin layer chromatography. Thin layer chromatography. So what you would be given would be a TLC plate, and these are pre-cut for you, so you don't have to worry about that. And you will be asked to essentially run a TLC and figure out the nature of your unknown sample. Now your unknown sample will be one of the 3. It will either be benzaldehyde, or it will be orthonitrophenol, or it could be metanitrophenol. Okay, one of the 3. Or it could be mixtures as well. So you have to tell me on the basis of the TLC result that you get as to what you got. Now, how do we go about it? We will have 3 different standards. So in the video you might find me talk about 3 spots, because when that video was developed we essentially had 3 component system, but in this case you have 4, so read that as 4. I mean, you can run 5, 6, 7, as many as you want. So I'm going to call that standard 1, standard 2, standard 3, and your unknown. It's a good idea to run a co-spot as well. And if you're kind of unsure, if you think that you may not be able to fit both of these or all of these in one TLC plate, which is the ideal situation or the most ideal situation, feel free to run 2 different TLCs, and that's okay too. Now, what you're going to do is you're going to take the standard of benzaldehyde, and you're going to put a spot on standard 1. You're also going to put 1 little drop at the ghost spot. You're going to do the same thing with orthonitrophenol. Let's maybe change the color just so we know that it's a different compound. So that's what you do, and a little bit in the coal, and then maybe metanitrophenol, so that's the third one, and then in the coal, and then I'm going to also spot the unknown. So I'm going to go with red for that one, and then that also goes in coal. And I'm going to then put this in the jar the way I have described that in the video, and I'm going to fill it up with about 10 milliliters. The filter paper and everything would be there. 10 milliliters of hexane, and I'm going to cover that, and I'm going to let it run. And as you go through that, just watch it develop, and right when the eluent goes all the way up to that edge, maybe about 0.5 centimeters or so lesser, at that point of time you can just stop running the TLC. You can mark the solvent front so that it's useful when it's time to calculate the RF value. And now you're going to simply stain it. Just let it dry a little bit, because you may not be able to see all your spots, and what I would recommend is stain it in KMNO4. KMNO4 stain. And as you stain that, you will see that some of these spots will show up, get highlighted. So I'm going to just mark, randomly, kind of what you might expect, and maybe you will see two spots. Maybe you'll see one here and one here, suppose, and the coal spot should show something here, and something here. Well, how do you read that information? Realize that coal spot is supposed to contain all four of these, and so that is the reason that you're seeing what you're seeing. The unknown in this case tells you that you have a mixture, because you have one component and you have a second component, and it also tells you that it's probably standard 2 and standard 3, so it's a mixture of two things that you have. So you have to identify, essentially the aim is to identify how many components you have and which ones are they. You could have, like I said, only a one component system, or a two component, or even a three component system, and that's what you have to figure out. What I would recommend is use technology, use your phone. So take a picture of the TLC as soon as it gets developed, and I want you to print it out and include that as a part of your conclusion. So put that picture, stick it in your lab report, and of course discuss that in the conclusion. Discuss that in the conclusion as to what happened. And if you took two TLCs, then you have to include two pictures, as the case may be. And I believe there are like 3 or 4 post-lab questions. Work on those and bring that with you, turn everything in next week. That's the lab.